continuation of the 2020 vision. BINUS University has set a vision of BINUS University 2035, a world-class university, fostering and empowering the society in building and serving the nation. The vision is equipped with strategic objectives as a guide to achieve the vision. Currently, the BINUSian community is comprised of more than 170,000 BINUSians. It has 55 study programs that have been accredited by the National Accreditation Board for Higher Education, School of Computer Science, School of Information Systems, School of Design, School of Accounting, Faculty of Engineering, Faculty of Digital Communication and Hotel and Tourism, Faculty of Humanities, BINUS Online Learning, BINUS International Program, BINUS ASO School of Engineering, Double Major Program, Master Track Program, BINUS Graduate Program, BBS Undergraduate Program, BBS Master Program, BBS Doctoral Program. BINUS University implements the best academic system through a 2+1+1 academic system. Students are given the opportunity to experience different teaching and learning processes. It implements multi-campus mobility learning, minors and enrichment programs. Everything should run in the ultimate digital ecosystem. Keep moving forward and transform. Always attract new stakeholders and create new student experiences. All of this is done to achieve the quality target of BINUS University, which is 2 in 3 graduates work for global companies or become entrepreneurs. As a world-class Indonesian university, BINUS University continues to make achievements by making outstanding performances at the global level. Performing activities at the international level, carrying out research activities such as through Research Interest Group and Research Center.
Good morning, everyone. It is my pleasure to host this international webinar. My name is Daniel, and on behalf of the entire Civil and Environmental Engineering Technology Seminar, I would like to extend a very warm welcome to all of you. We are pleased to have everyone here and greatly appreciate you for taking time off your busy schedules to join us in this event. Among us in this conference, we are privileged to have experts from Sejong University, Seoul, South Korean, Professor Hyosop Woo, our alumna of BINUS University, Ms. Ezra Nozomi Gloria Sompi, and Senior Water Resources and Flood Management Specialist, and Indonesian representative for Institution of Civil Engineers, Mr. David May, here in BINUS as key speakers for this session. We would also like to extend special thanks to Mr. Christian Cahyono as our moderator today, and to the rest of the attendees for the enthusiasm. We hope you learn a lot and find the seminar covering case studies in integrated engineering lineup for you today to be fruitful and engaging. To begin this event, I invite everyone to invoke the Almighty and pray with your respective beliefs. Let's take a moment of silence to thank God for gathering all of us this morning. Let us pray. Amen. To formally begin the seminar, I'd like to invite Dr. Oki Satyandito to deliver opening remarks for our attendees. Okay, before we proceed into the main session, a few reminders to ensure an uninterrupted event and to achieve a respectable environment. I would appreciate the cooperation from every participant. First, to mute your microphones at all times during the session. Any concerns or questions concerning the topic can be inquired during the Q&A session, either by the raise hand function in Zoom or through the chat box after each speaker's presentation. All participants are required to fill an exit ticket before leaving the meeting, which will be informed at the end of our webinar. Finally, participants are required to comply with the rules and regulations applied during the seminar. Now, I would like to invite Mr. Christian Cahyono to take over and lead the rest of our event. Mr. Christian Cahyono, the floor is yours.
Okay, thank you, Daniel, for the opening ceremony. Okay, let's get started into our seminars today. So, as Daniel's already explained, there are three speakers that gonna bless us with their knowledge today. So the first one is Professor Hyosoku. Okay, let me read his CV. Okay, Professor Hyosoku is a professor at the Department of Civil and Environmental Engineering in Sejong University, Seoul, South Korea. He has a lot of background in his education and his experience. First, the education in he takes Bachelor of Science in Civil Engineering in Seoul National University. His Master in Hydraulics Civil Engineering in Seoul National University also, and his PhD in River Engineering in Colorado State University. Okay, this is his work experience. He is a president of KICT from 2011 to 2014, chairman of International Association of Hydro Environment Engineering and Research (APD) Asia Pacific Division from 2015 to 2018, founder and president of Korean Society of Ecology and Infrastructure Engineering 2013 to 2016. President of Korean Water Resource Association from 2011 to 2012, and the recent one is Vice President of International Association for Hydro Environment Engineering and Research (EHR). Such a huge experience. He want to bless us today. So, Professor Hyosoku, I invite you to give us some of your knowledge to us about about the water infrastructure. If you please do already with the presentation, you can give us the presentation right now.
Okay. Thank you, Christian. I think you are asking me to give you my presentation this time. So, okay. Can I share, this screen with you,
Oh, yeah, sure.
Yes. Yeah. And then I think, Christian, do you see my slide?
Yes, I can. We can see your slide, Professor. Oh yeah, for the participants, you can put your your Q&A session on the Q&A chat box. So after Professor Wu finished with the presentation, you can I will read the question for Professor Wu. Thank you, everybody.
Okay. Thank you again. So, ladies and gentlemen, I think thank you very much for your invitation to this valuable webinar. And today I'd like to talk about NBS, nature-based solutions, and NNBF, natural-based futures, for focusing on water disaster risk reductions. So I may spend about half an hour to communicate with you with this topic. You see the contents. I start in a simple introduction of NBS and NNBF. Then there are already existing concepts which are similar to those concepts. So I need to introduce briefly existing similar concepts. Then I like to explain more in detail how to apply NNBF. I focus on NNBF today to water disaster risk reductions. So I like to show you many examples, and then I make a concluding remark. You see, I like to briefly explain what NBS and what NNBF are. So you see, I think many of you already know NBS, or at least you have experiences to learn to get touch with NBS, nature-based solution. It is a concept. It is the concept developed by IUCN, International Union of Conservation of Nature, sponsored by World Bank. It is action to protect, manage, and restore natural or modified ecosystems to address societal challenges, and then we expect simultaneously human well-being and biodiversity. So yes, simply speaking, it is the utilization of ecological functions and services for human well-being and biodiversity benefits. You see, and then what is NNBF? I think some of you already heard about this, but I think not all, because it's very new concept introduced to us years ago. It is an approach to the disaster risk reduction in the coastal, estuary, and riverine areas by utilizing natural and nature-based features. In this case, future means landscape features, such as we consider to expect a good benefits from coastal lines, natural coastal lines, sandbars, marsh, reefs, and islands for disaster risk reduction in the coastal area, and floodplains and wetland restoration in riverine areas. So in these two concept, we have two words, similar but different. One is nature or nature. The other is nature-based. So the first one is natural landscape itself, and second one is nature restored or even nature mimic. And I think what I'm talking about is how to utilize ecosystem functions and services. And there are four ecosystem functions and relevant services. I can show you with this diagram to explain, especially focused on water. Regulation service. By this service, we expect flood regulation. Provisioning service, we expect water. And cultural services, we expect aesthetic value of river, water, and coastal areas. And the supporting services, we expect nutrient cycling. And then background of these two concepts. NBS, as I told you, it was introduced formally, officially in 2008 by IUCN, but the origination of this concept came back to 1990s, such as in 1992 we had Rio World Summit, Rio Environmental World Summit, and then they accepted the Agenda 21 regarding water. Then we had Millennium Ecosystem Assessment for 5 years. Then this concept was introduced in 2008. On the other hand, NNBF You see, this concept was introduced officially in 2021 jointly by United States, Netherlands, England, Germany, Ireland, and World Bank. So a very new concept. And then we try to understand, we try to apply NBS already, but we have another concept, NMBF, which sounds similar to NBS, but could be different. So, and at this webinar, I try to delineate NBF and NBS. So this is the cover page of the technical guideline of NMBF. It's freely accessible in internet, and it's very thick technical guideline. I think more than 1,000 pages. You see, this chart was developed originally for NBS, such as there are many approaches of NBS here. For example, in terms of infrastructure, we already know natural infrastructure such as forest and green infrastructure. And in terms of ecosystem-based management, we have integrated water resources management, IWRM. And in terms of each specific ecosystem related, we have ECO-DRR. DRR denotes disaster risk reduction. And then ecosystem restoration, we have ecological restoration or ecological engineering. Among those different approaches, if I focus on NMGAP, we can make a red circle, this one, and this one, and this one. So I like to explain to what are differences NBS and NMBF and what are similarities. So NBS is utilization of ecosystem, natural or nature-based, such as restored and modified, to address safety from floods and etc. So any social environmental issues, problems, but NMBF only focus on water issues, flood issues, either in coastal, estuarine, and riverine areas. So difference. So the first one, NBS ecosystem, NMBF is special landscape, and NBS focus on safety and security, but NMBF safety from flood only. So I may say NBS in general encompasses NMBF. And then I like to spend about less than 10 minutes to introduce various concepts which already existed and sound similar to NBS and NMBF, starting from ecological engineering and even close to nature river works, techniques. You see, the similar concept one is ecological engineering. This is not practice, kind of practice. This is an academic discipline started from 1960s in the United States. And then a typical example that is dealt with in the discipline of ecological engineering is constructed wetland like this and green roof. So I do not go into detail. Second, similar concept of BWN, a building with nature. Look at this. This is a Dutch practice. And then instead of you see making this beach sand spread along the you see coastline to protect inside coastline against the storm surge, they just put huge amount of sand here delivered from deep ocean. Then natural wind and natural waves and even storm surge can make this dump of sediment spread along the coastal line. So they call it sand engine. Anyway, this is another practice. And then, this is a well-known concept, green infrastructure. But you see, there is two distinct meaning of this term. One is, I say narrow meaning, is how to treat storm water in quantity and quality by using nature mimic process such as bioswales, permeable pavements, green streets, etc. And if I expand the meaning of green infrastructure, they can also say blue-green infrastructure. It is the patchwork of natural areas that provide habitat, flood protection, and others, especially in the urban areas. I'd like to explain this more in detail with the relevant diagram. This is, as you know, examples of green infrastructures applied in the urban areas. And then this is the diagram showing the blue-green infrastructures. You can see patchwork of green areas, such as this one, and this one. Also, you have patchworks of blue areas. So you have a built environment, urban areas. You have natural environment. So they try to integrate by patchworks of green and blue networks. Okay, then eco-DLR, this term has been used for many years, separated from NBS or even NNBF. It means ecological disaster risk reductions. So this is a very good sketch, easily explaining eco-DLR. Suppose we have villages close to the natural hazard prone areas. So we may consider to construct grey infrastructure such as levee or retaining walls. Instead of them, we can consider to plant trees to make a forest belt so that this could protect villages against the natural hazards such as landslide. At the same time, we expect a small habitat from this green forest belt. This is called eco-DLR. There are many other examples here. And even we have LID, low impact development. I think many of you already heard LID. This is the practice which is similar green infrastructure. So I don't go into detail. This is one example. They make this kind of concrete box and rain harvest box to retain excessive storm water. And even we have a similar concept, close to nature river work technologies. This English term comes from the original German term, such as naturnahe Wasserbau. And this is examples. Now we try to make grey infrastructure. We try to make this channel to only considering flood protection by using concrete low revetment and concrete levee revetment. Then you do not expect any biodiversity in this case. If you restore partly this one to this one, you can expect biodiversity. That means good habitat for bio. This practice has two bottom lines. One is close to nature stream morphology, not straight, but meandering, and use of natural material. In this case, living material, willow trees and others. So if I combine those existing concepts which look similar to NBS or NNBF, I think now we can put LID here and green infrastructure here, BGI, blue-green. and ecological engineering, and eventually NBS. Then I think NMBF still a subset of NBS, but could include some of those existing concepts. So I may put a little bit arbitrarily here like this. And then I like to show you briefly numerous examples of a different spectrum, different category of you see, in this case, NMBF. I focus on NMBF. In this diagram, on your right side, you have gray engineering, art engineering, which we have learned from civil engineering discipline for the last, say, 100 years. Then next, we can consider a combination of green or soft or bioengineering plus gray engineering. Then we can consider nature-based, not nature itself, but nature-based futures.
We're trying to get SAT
Then-
points.
Can I continue?
Yeah, sure.
Okay. Then eventually, we can consider the last category, natural futures. So if I consider these three, we can say nature-based futures. But if I combine natural itself, then all of these are NMBF, nature and natural-based futures. So there are 4 categories, 1, 2, 3, 4. So I'd like to explain some examples for each category. Okay, then this categorization should be continuous, not cut. So I say a continuous spectrum. This is a good example. You know that it's in category 1, gray infrastructure. We can make by high techs, by engineering technologies to make this kind of barrage in Korea, in the Netherlands. And then if I combine green and gray infrastructures, you see super dike here to protect inside against storm surges. But in addition, we can consider to make man-made vegetation, wetland, actually marshland, to alleviate first the oncoming storm surge. Then eventually this gray infrastructure would protect completely the inside urban areas. This is examples. Another example could be found in Korea. Here we have breakwater, and we have dikes to protect inside against storms here. See, then in addition, we make this kind of tree corridor, forest corridor, like this in the real pictures, so that we even some parts of storm water could overflow this levee. Then this forest belt can protect inside urban areas by absorbing the overflowing storm water. You see, this is all the practice in Korea. They also made this kind of coastline forest belt to protect inside this case padland. You see another examples, eco corridor. I'm sorry, eco DRR. You see, I already explained this one, and this one is they planted trees on the levee, Ulsan levee, to protect Ulsan levee erosion. It was 400 years old, and even they planted trees like this, cluster, not corridor, to protect villages located here against the straight coming flood torrents during flood times. This is 1,000-year-old practice. And then case 4 is close to nature. River works techniques. this is German practice. They use, instead of concrete revetment for protecting this stream bank, they use the living material, willow trees, this and this. And this is in a very common practice in Korea. So we have this to this. And then category 3 is nature-based features. One example could be found restoration of tidal flats. You see, they made in a seaside dike estuary river in a ocean. But because of this dikes, the channel narrowed, and then storm peak could increase because of this narrowness. Instead of this, they set back levee to backward like this. Even they remove levee here to absorb a storm surge, peak of storm surge, so that they at the same time they can expect habitat functions from this restored wetland. This is an example of category 3. And this is in the actual views of those practice. This is in a setback. Levee setback is very common in Europe, Netherlands. There was a levee here. They set back that levee to this place so that they restore this floodplain. And this is a good example of their practice. Longford River, very well-known practice from the Netherlands. And then this is in the same case, levee setback, but in Korea, small scale work. And then even we may consider removal of levee. For example, we have a small stream here. They constructed a levee on both sides. Then this, especially this portion of the levee, is only for this small, narrow land, paddy land. By removing this levee, they can make more room for the river, and also they can restore this land, which was originally a part of floodplain. And then retention points, so-called washlands, important. And this is actual work in Korea. This is another example in the United States. You see, and then last category is just conservation of nature itself to get benefit from that nature. So natural features. This is a good example of mangrove forest belt. I think many of you already know, and then you may know better than I. This is a good example. In 2020, we had a cyclone Emperor. Then because of this mangrove tree forest belt along the coastal line, they had less damage as expected. Those without mangrove tree forest belt. And then tidal flats are also important. It's a part of coastal lines, but by conservation of this tidal flat, we expect in terms of flood alleviation. And this is a good tidal flat in Korea and other pictures in Korea. And even coastal sand dunes are important to protect inside. You see, look at this. This is the sand dunes in west coast of Korea. This is another sand dunes in west coast of Korea. And then this is good in a diagram showing how useful the natural sand dunes in coastal line. You see, suppose we have artificial retaining wall here. Then it's very susceptible to be destroyed by storm because the foundation itself naturally very weak. So this could be like this, but when you consider the natural sand dune, it's very flexible, so that once it is modified or just changed in shape, it could be restored. This is a examples in Korea, destruction of retaining wall by by the action of waves and storm surges. There are many other examples which you find in the NNBF guidelines. This is one example of Levis effect in the United States. And this is another example of side channel here, side channel construction in the Netherlands to expect flood protection as well as habitat restoration co-benefits. Okay, I think let's spend half an hour. So I need to conclude my speech this time. So again, MBS is a umbrella concept where we harness natural processes and ecosystem services to address our social environmental challenges in water sector, actually in every sector, NBS. So I may say all the approaches based on the nature. In this case, nature means ecosystem, nature-based solutions. On the other hand, NNBF, natural-based futures, it is the utilization of natural or restored or modified landscapes to address safety from floods. We focus only on safety from floods, either in coastal, estuarine, and riverine areas. So NNBF newly introduced in 2021, but the core concept is not new. So we may say NNBF is a good subset of NBS. And then we may consider there is a continuous spectrum of river and coastal line management in terms of flood protection. First, we used gray infrastructure, and we have used green plus gray infrastructure, but still we need to use nature-based futures, and eventually we need to protect, conserve nature itself, natural futures. In most cases, but NNBF shows a better efficiency when it is aligned with the conventional gray infrastructure. So in our civil engineering discipline, still we need to learn more in techniques, in technologies and science, how to design better, infrastructures using so-called gray. I think this is the last of my presentation. So I say thank you again for your listening. Thank you, Christian.
Okay, thank you, Professor Wu. Such an insightful presentation about nature-based solution for flooding and coastal protection, right? Okay, Professor Wu, there are several questions that comes to me asking about your presentation. Okay, the first one is from Farel. What do you think of the coastal zone management here in Indonesia, especially in areas vulnerable to the adversities of natural circumstances, such as the southern coast of Java? Is NBS and NNBF implementable in Jakarta, considering how extreme our climate is, which is ultimately triggers disrupting variables such as fluctuating river flow and groundwater level?
So you are asking me in Jakarta area, you have issues, water issues of groundwater depletion.
Okay.
Am I correct?
In Jakarta, there are basically the groundwater is very low right now because of so many our buildings taking the groundwater for their water source, right? So the groundwater level is so very low in Jakarta. So there is a land subsidence happens in Jakarta. So is there any what Farrell want to ask is whether is there any solution using NBS and NNBF to solve that groundwater level and fluctuating river flow happens in Jakarta?
Okay. Thank you, Christian. You see, unfortunately, NNBF only focus on, flood, risk management, such as storm surge in coastal area and, alluvial flood in the, channels, inland channels. So as long as the groundwater issue is concerned, I think, not NNBF, but NBS approach could be applied. But at this time, I'm not quite sure how can I answer that question because I do not have much information about the groundwater issues in your capital regions. So
Nice.
I have another chance to talk about that topic with you later.
I see. Thank you, Professor.
Okay.
Oh, okay. There are questions from Gaby, one of our assistants in BINUS. Is there a possibility to use NNBF as water disaster risk reduction in Indonesia?
That is simple. Disaster, water disaster, issues. Yes, yes. You see, as I explained in my presentation, there are many cases of application. There are many application cases, either in coastal areas and in you see inland alluvial channels. So it depends upon the site-specific you see environment. If you have some specific issues related to water disaster, you can consider existing application examples. For example, in the guideline or in other sources. So you can compare those, and then you can choose one good examples or applications. I think it's possible. Yeah.
Okay, thank you, Professor Wu. I think it is answered pretty well for Gaby. This one is from me, actually. So,
Okay.
As back in my master study in Universitas Katolik Parahyangan, one of my professors, Mr. Dodi Yudianto, explaining me about a river in Seoul, Korea, Cheongyecheon.
Yes.
Is it one of the one of the example of NBS and NFBF implementation in Seoul, Korea? Because
yes.
Can you explain it more clearly so that our audience can know what happened in that river and how it is NNBF implemented in that river? Okay,
thank you. You see, yeah, Cheongyecheon Restoration Project is one of the famous urban water restoration projects in the world, and it was completed more than 10 years ago. And the point is that, you see, there are 2 points. One is how to manage water in terms of quantity and quality. The second is how to restore, you see, cultural values of the old urban stream, because Seoul was the capital of Joseon Dynasty for more than 600 years. So to deal with the water in quantity, they first considered, they expanded the width of the urban stream as large as possible, so that they can accommodate a design flood, such as 200-year design floods and some others. But importantly, the water quality issue is important. So they reinforced the interceptor to to convey, you see, sewer from the buildings and the household in the urban basins to deliver those to the downstream wastewater treatment plant. Third one is how to maintain environmental flow, because in urban areas, as you know, you don't have much water in dry season, and in flood season, you have abundant water. But you need to maintain environmental flow to keep the stream alive in terms of aquatic habitat as well as riparian habitat. So interesting. They conveyed water, environmental discharge from the Hangang River, very large river, from about 5 to 10 kilometers away from the small Cheonggyecheon. So they continuously maintain a supply. You see environmental flow to that restoration site, so that the environment, aquatic and riparian, could sustain. That's the third point is important. The last one is how to restore the cultural, historical values, because the stream was a part of the Seoul for more than 600 years as a capital of dynasty and now Republic of Korea. There are numerous artifacts of cultural, historical remains. So they try to make a restoration of those artifacts as close to original features as possible. The last one, and it's not directly related to the project, but traffic issues, because it was in urban streetways. Also, there was a elevated highways above the stream. They removed all the elevated highways and you see street, concrete covered street. So in that case, you need to check, simulate what happens without those arteries of highways in urban areas. Fortunately, they could dissipate the existing traffics to neighboring alternatives, so that at this time we don't have any traffic jams in those areas. That's very important and good points. Sorry for my long explanation. Thank you.
Oh, thank you a lot. Thanks a lot, Professor Wu, for the explanation. Basically, it is trying to come back it to the original state of the river of Cheonggyecheon, because if I remember, there are highway for
Yes.
upper the river, so there are so many traffic jams in there, and then the the Korean government tried to back to the original state of the river, and basically there are historical part of that river that my professor teaching me. Okay, thank you so much, Professor. Okay, there are questions from our lecturer, one of our lecturer in BINUS, Miss Yureana. So basically, what you explaining is about nature-based solution and nature-based infrastructure. The question is, what are the operational and maintenance for this approach?
Say that again, please.
What are the operational and maintenance for this approach?
So still I miss what you are saying.
Okay, basically is that what you bring to us is about nature-based solutions and nature-based infrastructure. What Ms. Yureana asking is how the operational and maintenance for this approach.
Okay, you see,
Yeah, that's it.
I think you see, as I told you, if we only consider NBS or NNBF, in most cases, still is not economically acceptable or is not practically implementable, because they need, in general, larger areas for their implementation, and sometimes the land prices are very high, so that sometimes it is not economically feasible as compared with traditional gray infrastructure approach. So so far, when you especially consider to apply those approaches in urban areas such as built environment, you need to, always consider a combination of green infrastructure or NBS with existing traditional gray infrastructures. I think that's my, recommendation based on my, small experiences. Okay.
Okay, thank you, Professor Wu. There are and the other question from Farrell. There are several instances of erosion and sedimentation around ports in Indonesia. Once this sedimentation and erosion problems occurs, how effectively can nature-based solution and nature-based infrastructure to rectify them?
Okay, so you see, NBS and also NNBF, as I emphasized, they are not new concept. They are a integration of those approaches which consider the ecosystem functions and services in every aspect. So when you consider erosion and sedimentation issues in your watershed, I think you have a practice of crop cultivation or surface control in with some other practices. Those are still part of NBS, and those are still a part of NNBF. So I think existing approaches using the ecosystem or nature are considered a part of NBS and NBF. So I think you are doing well without acknowledging the NBS and NBF. So I don't think you don't need to make a very far advancing technologies based on NNBF or NBS. Yeah, that's my short comment.
Okay, thank you. And this is a final question, I think.
Okay.
What do you think of the coastal zone management here in Indonesia? Especially
well, you see,
Hmm?
I am basically fluvial river engineers, and I'm quite familiar with coastal water management. And I was in Indonesia only twice, so I'm quite familiar with the environment of coastal areas in Indonesia, because you are very big countries, many islands. So at this time, I don't say, okay, this is the right way to manage your coastal issue problems now. I don't think so.
Okay, because you only have come to Indonesia say twice, you basically you don't know how deep is the problem in Indonesia.
Yeah, I can imagine how difficult you deal with so many issues in coastal areas in your country.
Yeah, basically because we are an island country, so many coastal areas in Indonesia, so each coastal have different problems. So yeah. Okay, thank you so much, Professor Wu, for your insight about NBS, nature-based solution, and nature-based infrastructure. Okay, thank you for the presentation also and the answer. Hopefully the participants can can learn a lot from our discussions today. And thank you so much for the opportunities to speak for us, Professor Wu. Okay, we'll be sharing all speakers. Oh yeah, for the participants, we'll be sharing all the speakers' presentation in email along your certificates at the end of the seminars. Thank you so much, Professor Wu. Okay, we would like to continue to the second presenter. Who's the second presenter? Is it Mr. David? Oh, okay. Wait. I think, wait. So rate placement. Okay, the
If
host.
I can interrupt, I think I'm on at 11 o'clock, not 10 o'clock.
Okay, Prophet, Mr. David. Okay, wait for a second.
I'm all ready to go if you need someone to go now. But it looks like you found someone.
Oh, okay. Okay, this is for the second presenter. Miss Ezra Nozomi Goresampi. Okay, this is the alumni of our beloved civil engineering of Venus University. Basically, the education, she just graduated from Venus University last September, I think last November. And the work experience is junior researcher at Venus University and doing collaborative research project of Patimban Port in West Java and project management officer PT Mata Air Persada. Okay, time and places, Miss Ezra. Right now, I call you Miss Ezra. Back then, I'm calling Ezra. Do this, do that, do this, do that. Okay. Back then, you're just a
Okay.
student. Right now, you already a bachelor. Okay. The time and places it's yours. Please present. I don't know what you're presenting, but please present the best for us so the participants can learn a lot from us. Thank you.
Okay, thank you, Sir Christian, for the opportunity. Wait, I'm going to share screen first. Okay. Okay, is it clear enough in your screen?
It's clear.
Okay, so good morning, everyone. Thank you, Sir Christian, for introducing me firstly. And before diving into our topic of discussion today, I would like to express my sincere gratitude to SENS for allowing me presenting my undergraduate thesis research. And in this occasion, I would like to give you all the insight from my undergraduate thesis research, a study that I believe is one of the case of case study in integrated engineering. The title itself is Modeling Characteristic of Shipbuilding Force at Dock using the Smoothed Particle Hydrodynamics or SPH method. So briefly to introduce the background of my research, as we know, that Indonesian government has strategically planned and evaluated to develop strategic ports, especially the large ports that will be used as a domestic links by sea. And then in relation to this, considering the design to port, one of the requirements on designing port structure is to consider the impact that ships have on maritime facilities, including the transmission of kinetic energy from the ship to the structure and its transformation into straining energy on the structures and the fender systems. And then in this relationship between the ships and the port, the activity of ships and core to the port is a factor that needs to be considered when planning when planning the port to mitigate the structural failure. And then horizontal forces that can be received by the port itself due to the movement of ships when approaching its structure is the berthing force. And then to achieve this on approach using the SPH method can be executed that the characteristic of the force on the dock that occurs due to the ship berthing, it can be modeled by using the Lagrangian particle method, specifically using the smoothed particle hydrodynamics or SPH method using the Duels physics software. So the method used in this research, firstly, the berthing velocities case that is applied in this research, there are different cases, which is 0.2 meter per second, 0.3 meter per second, 0.5 meter per second, 0.6 meter per second, and the last one is 0.8 meter per second. Those berthing velocity are chosen without concerning the sea current. And then the object that is used as the ships in this research is 10,000 deadweight tonnage product and chemical tanker type of vessels. These are the vessel parameter that is used for the research that I took from Piang Standard. And then the flow of the research that I conducted is by doing the numerical modeling using SPH method, and also doing the calculation using empirical formula, and then at the end comparing both of the results from smooth particle hydrodynamic and then from the empirical formula method, and then come to the conclusions. So briefly about the smooth particle hydrodynamic or SPH methods in dual physics. SPH is basically a software, numerical method of simulating fluid flow. It is a method to represent fluid as a set of particles. So in dual physics, it's a specific software that employs SPH to simulate fluid dynamics, including interactions with the structures like waves in the context of ship berthing. And then come to the result and then the discussion for the research. From the calculation using empirical formula, I conducted calculations with the 5 different berthing velocity cases that I have mentioned before. And as can be seen from the table, that it yields different berthing energy and different berthing forces, different to the case of berthing velocity. And then this result proves that this not only the specifications and the dimensions of the ships, but also the speed of the vessels when maneuvering at the dock could affect the magnitude of the ship's impact force value. And then next to the modeling of berthing force using the smooth particle hydrodynamic or SPH method at using dual physics software. From these 5 case variations of berthing velocity, it is conducted by the smooth particle hydrodynamics. And then we can see that from this graph, there is 5 different graphs respectively to the each cases. So we can see that from this graph, there are this data that generated by modeling using this smooth particle hydrodynamics method. It is found in the form of positive and negative value, which these conclude that the value with positive notation is the amount of force due to the impact of the ships when colliding to the dock, and while the value with negative notations is the amount of force when the ships bounces back from the collisions. And then we can see that the peak positive value in these graphs are the critical value of the berthing force that we take as the value for that is conducted by the SPH method. So we can see again that from these graphs, the force characteristic is that the ship hits the dock with a horizontal force and reaches its maximum impact at the first 0.03 to 0.05 seconds when the ship collides to the dock, and then the ship bounces back and hits again to the port with a force magnitude that is lower than the maximum magnitude that happens before. So we can put it on the table that the berthing force result of 10,000 deadweight tonnage tanker without sea current using smooth particle hydrodynamic methods on its respective ship berthing velocity is as shown on the table. And then, yeah, the resulting force characteristic shows that the ship hits the dock with a horizontal force and reaches its maximum impact value at the first 0.03 to 0.05 seconds when the ship collides with the dock structure, as I've mentioned before. So then we can compare both of the result from the empirical method and from the SPH method. We can see that there is that the empirical calculation of berthing force and also from the berthing force that we have using SPH modeling, it shows a slightly different percentage between both of the method used. And we can see how this both of the SPH method and the empirical formula can shows a very slight uh, difference percentage. And then so we can conclude that firstly, the greater impact energy received by the dog from the ship berthing is influenced by the magnitude of the speed of the ships, and then the berthing force that the dog receives from a 10,000 deadweight tonnage vessel reaches its maximum value at 0.03 to 0.05 seconds initial when the ships firstly collides with the dog structure. And then we can see that both approaches, that this from the smooth particle hydrodynamics and from the empirical equations, show a similar correlation between berthing velocity and berthing force, with the difference of both approaches is relatively low, less than 10%. And also in this conclusion, I really love to mention, to underline the importance of integrating various domain in engineering, that making a collaborative approach as to yield innovative and not only innovative, but also effective solutions to various challenges in different domain of engineering. So in my case, in this discussion, I believe that it is an innovative approach to make a relationship in the civil engineering field, but not only in the civil engineering field, but also in the shipbuilding, or maybe in naval architecture field, as this type of research can help in ensuring the design of both the ships and also the port to withstand the force, and ensuring that the safety of both of the design from the port and the ships itself. So I think that's it from me. Thank you so much for your attention. And I give it back to Sir Christian.
Okay, thank you so much, Miss Ezra. Okay, we're gonna do the redo of our final thesis Q&A.
So true.
So true. Because me as one of the the one that asking her about the final question, the final thesis Q&A. Okay. Basically, what we do, the main theme of our seminars today is integrated engineering, right? So what I want to know is how you connect it is because your research is very civil engineering, very coastal engineering.
Yep.
How you basically integrate it into the integrated infrastructure of civil engineering in our seminars today. How you put it? How I put it, like how you integrate your research into the main theme of our seminars today. Can you please explain it to me?
Okay, so Christian, thank you for the question. So I said that before on the conclusion part, that the importance of integrating the various domain in engineering, as in my case with this research, I believe this research is not this type of research not only can be usable for civil engineer, but also can be usable for the shipbuilding or the naval
Good. Error. Okay. Wait for Miss Ezra's. I think the signal is pretty bad there. Yeah. Oh yeah, for the other participants, please, you can put your Q&A sessions in the Q&A chat box and ask yourself to the speakers, okay? Because I think they. Okay, disconnected. I I want to remind you again to the participants, please ask because the presentation is very good. Ask them yourself because it is basically you didn't get that you get that in classroom, so you can ask what you want. Basically, what I if you don't have any you don't know anything even anything about the you don't know anything about the presentation, please ask them yourself. Oh, okay.
I think there's slight connections issue. I'm so
Okay,
sorry.
I know. Okay,
Mm,
please. Okay, thank you, host. Okay, you can repeat a bit and then continue.
Okay, so the answer to questions before
Yes, yes.
is that I've already mentioned on the conclusion that this type of research, I believe, can be used not only for civil engineering but also to the shipbuilding or maybe naval architecture related field of engineering, because this research can help in like ensuring the design, not only the design of the port but also the designs of particular ships that will be used in particular ports. I think that's it.
Okay, thank you. And before we gonna continue to Q&A session, thank you, Miss Professor Wu, for the opportunities, and hope we can have another chance to talk to you and maybe collaborative research. Haha. Thank you so much. And then the next question is from this is from Mr. Hafiz. Uh, the one to teach you SPH. Okay, let me see about
Oh my
the
God.
question. Question from Mr. Hafiz. Do you consider the vendor material for the collision response in the simulation?
Okay, thank you, Sir Hafiz, for the question. I believe you already know this too well. But I did not consider defenders type of this defender type for the collision response in the simulations, because I only focus on the berthing force of the ships to the docks. So I did not really dive in too much to the material for the fenders. So the material of the fender is not one of my not of my one of my considerations, so I didn't put it in my I didn't do a lot of research to the fender material on this research.
Okay, basically you only focus on the force, not the material, because the material
Yep.
will gonna give a different response, different material, different response. You only focus on the force. Okay.
Correct.
Oh, there is a question. New question from Jerome Credo. What are the difficulties or challenges in this application? What he means in SPH, use or this research in general, basically challenges to do this research.
Okay, so firstly, the most challenging part for me is because there is so lack of proceeding research related to SPH. So I really encounter a big challenges in looking for the references and stuff about the berthing force using SPH simulations. So that is the first and foremost the very challenging part for me. And also when trying to learn about the SPH simulations and just dual physics in general, it is really super challenging because dual physics is a pretty new applications, and there is not that much of references and tutorials you can find on YouTube's or maybe on internet. So you have to really dive and you really have to dedicate yourself to learn about this particular applications, as it's really new to the field and specifically on the field of civil engineering. So I think that is the most challenging part for me when I try to conduct this research and using this application in general.
Okay, yeah, because SPH is pretty new for us.
That's it,
It's
sir.
a new application, even for civil engineering business. So, and not many examples from YouTube or other like journals or anything. Okay,
Mhm.
basically that. Okay, maybe there are. Is there any other
Yeah.
question from the participants? You can send it on Q&A or chat box. Okay. Okay, let me see. Okay, what I want to ask ya. I think because I already listened this, maybe this is the third or the second time. What I want to know is, how impactful your
I
research
think it's a
to.
second.
I think the second. Oh, okay. Forget. It is because it's way back then. How impactful your research? Like the result of your research, how impactful, how impactful, and what does it is implemented for of your research. Basically, your research is find the burning force. That burning force, what the uses of that burning force to on design in civil engineering.
Okay, so the implementation first is to when we want to like design the board, it is really crucial to know the horizontal forces, and one of them is the burden force. So it's really super impactful to the civil engineering fields, because especially on the structural field and maybe on the water resources, because on how we know that that horizontal force is really can be super destructive if we don't like design and plan it really well. So by using SPH, it is a really effective method to know about the burning force, so that uh it can help civil engineers in knowing how much the burning force that can be received by the structure from the boards. Yeah, I think
Okay,
that's it.
basically, the horizontal force is for
Yeah.
designing the structure of the port, right? The port, it is, we know the in structures, we know that there are horizontal
Yeah.
force, the vertical force. We know that the vertical force is from the self weight or anything from the uppers, the dead load or the live load. But in port, as we know, and this is for the
Yep.
participants, the horizontal force is come from like the burning force and from the water itself, the tidal wave or anything, the wave from
Yep.
the sea. It happens. It impacted
There are many factors. Yes.
there are many factors that impacted the port. So basically, we gotta design the structure considering the vertical forces and the horizontal forces, which is come from the burning
Correct.
force and the wave. Okay, if there are no other question for you. You save another another final Q&A sessions, but you already prepared this because you already do it once. You can
Oh.
always do it the second time, the third time. Okay, thank you, Ms. Ezra, for the presentation, the insight of your start, the
Thank you so
final
much.
study. Thank you so much for the opportunity. Okay, that's it. We can move to the
Thank you
third.
so much, Sir
Thank
Christian.
you. We can move on to the third presenter, Mr. David. Okay, I'm gonna read the CV from Mr. David. Okay, from Mr. David, I don't know. Please correct me if I'm wrong. He is a senior water resources and flood management specialist and Indonesian representative for Institution of Civil Engineers. Oh, this one you from ICE, one of the part in BINUS Civil Engineering is part of ICE also. Okay, next one. Is there any? Okay, background education is Bachelor of Science in Civil Engineering in Swansea University, UK in 1971, and he takes his Master of Science MSc in Irrigation Engineering in Southampton University, UK in 1976. Okay, and this is his work experience, an independent consultant from 2010 and until now, 13 years. A lot of experiences. Hydraulic structures engineer, resource management specialist, team leader, project manager at Black & Veatch. Wow. Previously known as Bini and Partners and Bini Black & Veatch. Design and construction engineer or project manager at North Central State Water Board, Nigeria or VSO from 1973 to 1975. A lot of experiences. Please, guys, participants, ask the question because he has a lot of experience. Okay, time and places, Mr. David. Is you can present.
Can I share my screen?
Oh, of course. Just click the share screen.
Can you see that?
Okay, yes, we can see that, Mr. David.
Okay, so I'll try and find. Now I've got the top line is covering the presentation. So how do I move that?
Okay.
Can I move this top line somewhere? Because it's a lot.
Oh, just click. Click the F5.
Hold on. I think I can do it now. Slideshow.
Yeah, and from beginning. Oh.
Okay. Can you see that?
Wait, it's still error in our screen because it's still loading. Oh, just click. Oh.
Everything seems to be getting covered.
Yes, I can see in my screen.
Take me to the. Yeah. The thing is, I don't have it fully on my screen.
Full screen. I just clicked the bottom part. You can click it here. Wait, let me. Where the heck?
Hold on.
Yeah. Just from current slide, you can.
Can you see this?
It's still not fully on full screen. Oh, from Mr. Ed. Augustan is yes, I can see my screen, Mr. Dave. Yeah, we can move on. I think.
Can you see it?
Yeah, everybody practically can.
Yes, Mr. David, I can see it from my screen.
Okay, thank you very much.
Clear.
Just to the front to say it's a presentation, so I'll go to the next. What I'll talk about is what is integrated water resource management. Integrated water resource management requires a lot of integrated work by engineers and a whole list of other specialists. So it truly is an integrated subject. What is sustainability? The river basin and integrated planning. My early experience with river basins in Aceh in 1986. The Tulangbang River Basin Master Plan 1988. DGWR converts to river basin planning units for planning. Chimanuk Garung as an example. The World Bank and ADB supporting Chimangis, which I'll try and explain. Example of a river basin transfer and climate change impacts on water resources if I have sufficient time left. So you should tell me when I should stop talking. Unfortunately, the last 2 days I've had flu, so I better apologize for any coughing that may start. Start video. Oh, sorry. Now I see the problem. Okay, can you hear me?
Yes, yes, we can hear you.
Can you see the screen okay?
Yes.
Yes,
Okay.
sir. Loud and clear.
So what is integrated water resources management? I think ADB and the World Bank came onto this very brief description, but it actually goes into several pages. Integrated water resource management, IWRM, is a process that promotes the coordinated development and management of water, land and related sources in order to maximize economic and social welfare in an equitable manner without compromising the sustainability of vital ecosystems and the environment. So I'll go on to the next one. So in that case, what is sustainability? And sustainability is the integration of 4 main aspects: environmental protection, economic and financial aspects, which include technical, social aspects, and institutional and capacity building. If you can integrate these 4 items into your work, you can describe yourself as being sustainable. I'll take a little bit of time on this because for me, the main item about integrated water resource management is treating the river basin as a main planning unit. So this diagram tries to demonstrate all aspects of that. It'll take me a little time to go through it, but I hope you can see that water, collecting water, treating water, supplying water is a very complex problem, especially when you have all sorts of environmental problems. So if the little box on the left, A, is the river basin, and you can see this with the blue line. Sources of the headwater region. So up here is where a lot of the water collects. And then there's the transition region in the middle section here, where quite a lot of activity goes on with water. And then there's the floodplain or river mouth region here. And we need to govern this area. So we have, as well as the river basin boundary, we have an administration boundaries. Sometimes this is shown here as a kind of arbitrary boundary. And so we have transboundary river basin management. So we manage the water in this area as well as this area, even though this may be a different Kabupaten or Kacamatan, we still have to provide it with water. And then B3, upstream and downstream inequalities. People in the upstream here, they have first choice in obtaining the water. And the people the people at the bottom, they're second best. They have to rely on what's passed down to them. So there are inequalities. Water sources, well, you can see a rainfall at the top, and then runoff down here. Rainfall here, runoff here, and then river flows, and there's groundwater shown here. And then we have different water infrastructure, weirs, dams, and reservoirs. There's a dam here. This is maybe a reservoir or a lake. Canals. We have a canal coming off here, and here we have a pipeline from the groundwater. Demands. So we have agriculture demands asking for water, and by the way, Indonesia uses 70% of its water use is on rice irrigation, which is a hefty amount. Aquaculture down at the bottom here, aquaculture. Water supply. So here we have a city here, and we're supplying water from the groundwater. Land use. We have forests up here. We have a coastline here, and we have a monocrop plantation somewhere. I1 is a monocrop wherever that's got to. Oh, over here we've got Kelapa Sawit, I think. There are environmental issues, flooding, erosion and landslides, sedimentation and accretion of sediments, saltwater intrusion, river meandering, water pollution, increased runoff. So this shows you many of the different issues that have to be all brought together in managing the water within a river basin. I've been through this list, and there's something I've left out that's very, very important, and I'll talk about it later, and that's climate change. So I'll first of all go to one of my first inputs in Indonesia was in Banda Aceh as part of the Aceh Design Unit and Provincial Plan 84 and 80 to 88. And perhaps we were a little ahead of the Indonesian government in that we produced a provincial plan based on water resource development areas. So you can see them here. There's this is Krung Aceh, and this is Krung Baro Tiro. This is Pusangan. This is Jambuaya and Krung Pasay. This one is Tamiang, Alas here. I think this is Kluit. Is this Marabo, or this may be Marabo? I can't remember. And then we have Tanom here. So I've missed two out because I can't remember them. But it was some time ago. And what we did was we identified existing irrigation schemes. We proposed new irrigation schemes. We documented the water supply schemes, and we looked at existing and potential hydropower schemes. And at the same time, our group was training a provincial irrigation team in planning and design, and going to the field with them, doing site investigations, doing planning, doing design. And then we were also visiting the Kabupaten offices to help them with their design, construction supervision, and operation and maintenance. And everything was, we tried to organize it on a river basin basis. So that was my first experience. I went back to Aceh after the tsunami, and we had a project to rebuild 94 small irrigation schemes, which are mainly mentioned here. There's some in Nias as well. and these are about half the irrigation schemes in the province. So you can see there were very many. And it was interesting to go back to Aceh after something like 15 years. My next input was more formal water resource management. It was the Tulang Bang and Masuji River Basin Master Plan. I've just shown Tulang Bang here to make it not too complicated. But this part of Lampung is very agricultural. So the planning was very much orientated towards agriculture. Perhaps the boundaries aren't very well marked, but here you can see we had 7 sub basins: Tulang Bang, Wei Kanan, Wei Kiri, and Wei Sunkai, Wei Rer and Wei Basai, Wei Umpu, and Bahuga. And then as a cross-reference to this, we had what were called agroecological zones, where we could plan the agriculture and the irrigated agriculture. I don't want to go through every one, but they were split into mountain zones, hills, plains, and alluvial floodplains. Because the project was with the Directorate General of Water Resources, we also focused a lot heavily on irrigation development. And one of the firsts in Indonesia was that we built a water resource management model of the basin. We were involved with DHI, who did the basin, and their WRM model was the forerunner of the Mike Basin, which they sold all around the world and never gave Binion Partners a share. And we ended up with very complicated looking maps in Technicolor, showing all our proposals for the first 10 years, and there's another map for the second 10 years. So you can see we've got the hill zone here, and conservation areas, and here we've got the prawn farms, and the blue here are irrigation schemes. Actually, this part of Lampung is not very conducive to irrigation, so we had to wait till we got down to the floodplain of the Tulang Bang River before we could find any substantial areas. The yellow ones were schemes we looked at, but did not find to be so economic. So we get to the 1990s, and the Director General of Water Resources becomes very interested in converting their organization into river basin development units. So each major river basin in Indonesia now has a balai. So they've developed river basin boundaries, and for into province boundaries, they have what's called the Balai Besar Wilayah Sungai, BBWS. If the river basin is just in one province, it's just called the Balai Wilayah Sungai. And it enabled the development of a basin pola, which is really getting together all the river basin stakeholders and finding out what their concerns are and their future planning and how they can integrate their work together so that you can have multi-purpose projects, not just one agency having their own separate project and another agency wanting their separate project. If there's a benefit in combining, such as building a dam for water supply, irrigation, and hydropower, then they should come together. So at basin level, the Balais were managing several different things, starting off with a polar where up here you can see the polar. The key stakeholders were having meetings about water concerns and their plans. And then they worked with usually local consultants or consultants to prepare a sustainable management plan for the basin, that called the Ranchana. And that was supported by a river basin allocation model, so that uh, they worked on the hydrology to see what the dependable flows in the river are, and then they can allocate it to the different users, from irrigation to water supply to industrial to fish farming, whoever is demanding water. And then more recently, we've been working with them on a river basin flood risk management study and mapping. And so when they've identified projects that look economic, the first thing is we go back to the polar in an identification study to look at the development constraints, the possible solutions, and the multi-purpose benefits. Then for the particular project, there's a master plan study where we study the existing situation, scenarios and options for development, and preferred strategies. And then that passes through to a feasibility study where we're looking at concept designs and costs, scheme benefits, economic and financial analysis, and we select our best strategies and options for going forward for detailed engineering design, a 5-year action implementation plan, long-term plan, and a sustainable management plan, so that we know how to manage the project once it's complete. So starting off with the polar, I found this figure on the internet, which I thought was really interesting, because it's showing the equivalent of a polar. And I know that if there was a polar meeting in Indonesia, everyone would be wearing batik. So this is clearly somewhere in the West. And here you can see the director here looking a bit confused, where his right-hand man is explaining the whole plan. You've got someone from one of the agencies complaining here about something. You've got someone from a university here looking at it in great detail. We have a fisherman here who's putting forward his view about what should be done. And then we have construction companies who want to build things. I'm not quite sure what he's doing. Is he a schoolboy? I don't know. We have a reporter here, and we have some residents here putting forward their views. We have the accountant here, and we have a development specialist here. So I thought that was quite interesting. And they're looking at current issues, current and future demands, future water planning, what opportunities for multi-purpose and multi-agency plans. So what can we do together in an integrated way rather than doing separately in a non-integrated way? Because at the present, you can see so much water is running to waste off the table. This is the Chimanuk Chisangarung River Basin is one river basin I've done quite a lot of work on. So I'm showing this as this is from the polar. This is one of the polar and Ranchana maps, and you can see that it's called the Chimanuk because here you've got the Chimanuk. But it's actually comprised of a lot of very, very small separate basins here, and the Chisangarung basin here, which is the second largest. And so rather than have something like 2,000 river basin organizations, they've they've combined a lot of smaller basins within the main river basin, and you can see them, they're all listed down here. So not just one river basin, but many smaller ones to make management easier. And this is showing a schematic, but it's also similar to the river basin model that has been put together. So you can see where the rivers are and where the proposed reservoirs are. This is 2013, so the Jati Gadai was not built at the time, so it's shown in red, whereas the existing reservoirs are shown in blue. This one is under construction, Chipanas, but not the transfer canal, which I think is a mistake. But never mind. So you can see that the Balai now is looking at the river basin as a total unit, and they have to be involved in managing the water to all the different upstream and downstream users, as well as ensuring the environment and ensuring the sociology of the people, that they're not too much interfered with. And I'll come on to that next. Oh yeah, this is interesting because they've done a balance for the basin, and you can see this is the water flow. This is the maximum recorded water flows in the river, and this is the mean. And here we have the demands. So you can see the mean demand is already being constrained here, and when we have the one in a 5-year flow, you can see that even more so. And it's not going to get any easier, because by 2000, this was in 2012, by 2032, you can see that the demands have increased by about 50%. And so our reliable flows are well short of the demands. And clearly that's one reason for Jati Gadai Dam. So if I show you, this shows the excess water we have in the wet season in the 1 in 5 year situation. So if we can store this, here, at least for these months, we can satisfy all demand. These volumes are similar. But what are we going to do here? It probably means that people growing rice here, some of them have to grow other crops or reduce their demands, because even in November was short, and October. Now, I worked on a project in 2000 to 2000, from 99 to 2001, I think, Jati Gadai and Lower Chimanak Basin Study, where our terms of reference were to look at Jati Gadai Dam and how can we use the water for new schemes and for existing schemes. This big red green blob is the Rentang Barrage Rentang scheme, which covers, I think, about 84,000 hectares. So it's quite a large area. Some of these were already existing schemes, but they were short of water. And one of our problems was what to do with the people that were living in this basin. And we came up with this. We interviewed them, and they asked for 3 things. They asked, 1, to continue rice farming, 2, to stay in a Sundanese speaking area, and 3, to move as a community. So we tried very hard, and when we found this very nice dam site here, and this was a teak forest that had been absolutely destroyed. So we came up with the idea of resettling them here. Yeah, unfortunately, that didn't happen. And the study was done for the World Bank. Um, the World Bank didn't think at the time that it was a good idea to invest in a large dam. So it was built under Chinese aid funding, which is a shame. If you notice, this catchment area is very small. So the Chipoless River comes through here, and we proposed a transfer that was, I'm still trying to propose, that actually fills this reservoir every year. Whereas at the moment, it only fills, in a 1 in 5 year, it only fills to about 40 or 50%. Anyway, all these different areas have the different colours mean different things in the planning stage, and they're listed here. So if you're interested, you can get a copy of this. I came back here because although that was mainly irrigation, I've also been back on working with the ADB on this TA, the preparation of enhanced water security investment project, where we looked at the whole of the lower Chimanook, with water coming from Jati Gadai through here and through towards Chirubon. I actually found there's an existing reservoir at Chirubon, and there's quite a good new site. And I thought, well, maybe they were better off being supplied here. So this was one option, as well as a pipeline here. And then I also came up with the idea of dropping water from the dam and picking it up here, and then supplying these towns from Chipanas. But I believe now it's going to all be supplied by Jati Gadai through a pipeline going up here. And we also looked at flood risk. So this shows you the flooding areas in this area here. Some quite severe flood risk, very high. Some medium. We don't seem to have many yellow areas for some reason. And we also looked at the Chisangarong, and you can see that it's the lower part of the Chisangarong, as well as a few little areas along the main river course that suffer from flooding. So we've looked at the different aspects of water resources in this one river basin in communication with the Balai. And river basins don't have to be independent. If you have one river basin that has a lot of water and other river basin that has a lot of development and not a lot of water, you can have an interbasin transfer. And this is a project I worked on in Vietnam for 10 years, off and on doing feasibility and different studies, and finally producing a management plan. But you can see the B River here has 3 large dams and for hydropower. And these large dams mean that the dry season flow increased from about 12 cumecs to about 54 cumecs. So we were involved in suggesting the design of a barrage here and a transfer canal, a 42-kilometer transfer canal. And this could take off 75 cubic meters a second. It could give 5 to this province for their development, either irrigation or industrial development. And then 15 cumecs for this new city here, this industrial city, which was going up very rapidly. Vietnam is developing incredibly quickly. And 55 cumecs went into this reservoir here. We increased the reliability of flow to this existing irrigation area, and we proposed 2 new areas here and here. We also provided a transfer to Ho Chi Minh City, previously Da Nang, no, not Da Nang, Saigon, for 12.5 QMEX. And also these areas had DMI, so domestic, municipal and industrial water needs, as well as the irrigation needs. And down here, this river, the Vam Co Dong, has a lot of saline and sulfur soils that needed dilution to keep so that they could grow rice and sugarcane. Do I have a bit of time left?
Sure, you just go on, Mr. David.
Okay. I'd just like to talk about climate change impact for Indonesia, and you're going to have increased temperatures will increase evapotranspiration and water demands. It'll make work outside more dangerous due to heat stroke, particularly for people like farmers. They'll have to work in the mornings and afternoons, not work in the middle of the day. There's going to be increased storms that will cause more intense rainfall and runoff, increasing flood risk, erosion, landslides, and sedimentation. Sea level rise and storm surge will cause coastal erosion and saline inundation, reducing rice cultivation over about 1 million hectares by 2050. There will be increased pests and temperatures that will affect forests, crops and health of all creatures, including humans. So that there's a list of things that are anticipated with climate change. And I'm afraid Indonesia may be in a very vulnerable situation. So if we look at predictions of increased sea level rise, we see that by 2050, we're talking about just over, in the worst scenario, we're talking about 0.5 meter rise. Other people are now predicting even higher rises, up to about 800 millimeters. So that could be a problem. And then when we get to 2010, we're up in 1.5 meters sea level rise. And when you add storm surge and waves on top of that, it means that anywhere below 5 meters above sea level could be inundated by saline water, and you can have an increase in erosion. I did a brief study of where land was below 5 meters that could be affected by sea level rise, particularly this area, because they also suffer a lot of typhoons. When you have surges in Bangladesh, the surges can be up to 10 meters. Along the coast in Vietnam, about 3 or 4 meters. And we know that the Mekong Delta is settling as well as suffering from erosion and tidal surge. In Indonesia, we have the coastal area of Kalimantan is very low lying, and also swamp areas along the coast of Sumatra. And on my projects in Jatilahore, I've seen erosion and inundation occurring on this north coast of Java as well. So that's I mean, rice is a big staple of diet in Indonesia. So this is a worrying trend, and you may find that importing rice becomes more and more expensive. So if I just go on, this is the last slide. I don't suppose many people noticed that about 2 or 3 months ago, thousands of baby penguins died in Antarctica because the ice broke up. So because the climate in Antarctica has increased by 3 degrees, meaning that once stable ice shelves are now retreating, and the penguins which have their chicks on ice floes. The ice floes are melting before the penguins can learn to swim, which is a big problem. But how does it affect Indonesia? And I'm trying to show you here. There's what's called the South Equatorial Current that passes around here, and you see when it passes through near Antarctica, it becomes very cold, and it's very low. It's very low in the sea. You have warm currents coming through from the Pacific. In this place here, you have one current going north that is cold at low level, and you have a high level current going along the coast that is warm. And as these currents come through, and as the water is heated here, the current comes to the surface, and it's actually helping to cool Indonesia, not just this part of Indonesia, but these parts of Indonesia as well, because the flows are coming through and taken by the current. Now this current is driven by several factors, one of them being the difference in temperature between here and here. And there's been a study by Sheffield University, and they predict by 2029 this current may well weaken and Indian temperatures may rise rapidly. So that's a bit of a concern for Indonesia. And so that's me finished. Thank you very much for listening.
Okay, thank you, Mr. David, for the presentation about integrated water resource management, especially in river basin management. Okay, there are several questions for you, Mr. David. Okay, the first one is here. Let me read it for you. In other countries, some of their river have completely dried up due to human use and temperature rise. Are there any way to recover this dried up river basin, or is it only possible to prevent the dry up?
No, well, I think you find that in a lot of river basins, one of the reasons is that they dry up because the forest has been removed, and the soil cannot hold the water. The soil dries out very quickly. If you have a forest, particularly a tropical forest, the soil is almost permanently wet and holding water, and so is the biomass on top of it. So you tend to get a reasonable dry season flow. But in places that have a much hotter climate and drier climate, they routinely have dry rivers for 6 months of the year. And often water is taken from the bed of the river rather than the surface. My first project overseas was in Nigeria during a drought, building small dams to try and hold the 3-month wet season, hold the water so that the people could use the water in the villages for the rest of the year. And even when the surface water had disappeared, they could still get water from the bed of the river. You often find that in drier climates, the river surface will dry out, but there is still water underneath the surface, and it's gradually flowing to the sea through the soil. So one way to tap that water is by infiltration galleries. But at the same time, you really want some water flowing in the river to support the biodiversity.
I see. Okay. Basically, we can build a structure like a dam, a dam to fulfill the water needs. Okay. There are another question for you, Mr. David. Thank you for a very interesting presentation, Mr. David. I have a question. In the case of Cimanuk Cisanggarung water basin, who do you think the key stakeholder to ensure the sustainability of its management?
Sorry, so if I got that right, the Cimanuk Cisanggarung,
Yes.
what do we need to do to try and provide sustainability?
the key stakeholders to ensure sustainability, the key stakeholders to ensure the sustainability of its management.
Well, the key stakeholders are the farmers and the people that live on the banks of the rivers, and they're the ones that are mainly at risk if the river fails. And then, of course, all the agencies that should be supporting them.
Okay, basically all the
So,
stakeholders.
so
Okay.
if you saw that slide of the table with the water running off the table, in that case, the people at the table would be representatives of anyone who had an interest in water. Even householders who, because they need clean water.
I see. Okay, thank you, Mr. David. Okay, the last
I mean,
question.
I just add one thing that I never said
Okay.
before is that for the last 4 months, I've been an MBS specialist for the
Mhm.
flood management of Chimanutchis and Garong, and the Saluna River Basin near Semarang. So I've been trying to design MBS solutions for slope stability um, on riverbanks and where canals cut through steep slopes. So the idea is to try and replace, where possible, to replace concrete and masonry with vegetation like bamboo and vetiver grass. In severe cases, we've come up with hybrid solutions with gabions and with geomats, geogrids.
See. Okay. Okay. Maybe this is the question for me personally. You said that there are projections that the because of climate change that evapotranspiration we're gonna be go up, right? But as we know, the water demand for us humans, especially in Indonesia, keep rising because there are population growth in our countries. So to meet the water demand, that it means in if we build a dam to accommodate the water demand, the water is limited, right? The water is limited, especially it keeps going down because the evapotranspiration is going up, which means a lot the water loss will be more each and every year. But as we know, the people growth is keep going up. How we accommodate that problems, so we as a people get the same amount of fresh water each every year.
Well, one of the biggest users of water is rice irrigation. And the Department of Agriculture has been trying to pilot what is called SRI rice, which is intermittently irrigated rice. So it's not inundated all the time. It's not having a great deal of success persuading the farmers to change to it. Another strategy we've been trying to push as part of the Asian Development Bank is to try and change areas of permeable soils from growing rice to growing diversified crops, if possible by piped irrigation, sprinklers and drip feed. Because if you grow a vegetable crop with drip feed, you use about a fifth the amount of water you use to grow rice. So there's a huge saving there that could be used for increasing flow to the cities as people demand more and more water. As well as the government is on a course. I think there's a 36 dams being built in this 5-year period, and I think another 18 in the next 5-year period to try and try and trap wet season flows for dry season use, as I showed for Jati Gade.
Okay, basically we gonna diversify the crops, the plants, except for changing it from the whole season is use from paddy from into the vegetables, maybe
And
other
fruit.
crops. So the
Yeah,
excess water we gotta be we can use it for meeting the growing demand. Is that it?
Yeah, I think as Indonesians develop and become richer and better educated, I think you'll find that the staple diet of just rice with just a sauce will change to eating a lot more vegetables and fruit. The what drives farmers is the prices in the market. So if they believe they can earn a lot more money growing vegetables and fruit, even if they have to pay for irrigation systems or part of the irrigation system, eventually they will change. You can see it happening in other countries, like particularly Vietnam and India.
Okay, I think so. We can change our diets, right? But in Indonesian, we gotta say we don't eat until we eat rice. So
Yeah, well,
that mindset is still in Indonesians' mind.
yeah, yeah. Well, I was, if this had been an in-person presentation and there was an audience, I'd have made it a lot more participatory. And the first thing I would have asked is hands up all those that drank water this morning or something made from water like tea or coffee. And secondly, how many people how many people ate rice this morning? And I suspect that would be a high proportion. But
Yes.
does everyone know where the water comes from? How it's taken, how it's abstracted, how it's treated, how it's pumped, how it's distributed. It takes a lot of different specialists in an integrated way to provide you with not only water but also rice.
I see. Basically, that's the that's how you manage to fulfill the water needs. Okay, I think the last question is for me also. Use in your presentation you talk just a bit about mic a software called Mic Reservoir or Mic
Mike Mason.
Mic Basin. Can you just please? I'm a little bit intrigued by that. By Mic Basin. Please just explain me just a bit about Mic Basin.
Well, Mike Basin simulates flow at different nodes in the river systems, particularly the reliability you need to analyze. If irrigation is dominant, you tend to use the 1 in 5 year flows, and you see how many of your demand centers can be satisfied. If all the existing demand centers can be satisfied, you then look at the reliability of providing new projects with water. So it's a very useful planning tool for the basin. Actually, I in a different version of this, I had the Chimanook River Basin model that Binney and Partners designed, which is very similar. The Mike Basin you used to have to buy it from DHI, whereas there's a WRMM model that was free on the internet. So a lot of people preferred that.
Okay, basically models the river basin, not for flooding, but to design the water demand, like a water balance in
Yeah,
one river basin, right?
that's for water distribution, supply and demand balance. Whereas you use Mike 11 or HEC-RAS for flood modeling.
Yes.
So they'd be two
Right.
completely different models.
Mhm. Yes, yes. Basically, I use HEC-RAS for flood modeling also. Okay, thank you, Mr. David, for insightful presentation. Is there any other question from the participants for Mr. David? No one? I think this is a very good presentation, very good insight to us about integrated water resource management, because in Indonesia we usually talk about flooding, but no one, basically not really much people to talk about the water balance, meet the water needs for us, because it is water is part of our life. We need water to live, right? Okay, there are no other
Yeah,
questions. I think
I think I gave
Yeah.
a presentation I prepared was given to BNS about a year ago or 2 years ago, where I showed all the different specializations that could be followed in water resources. At a, an even earlier presentation I gave actually at BNS, I asked the people uh, the people listening how many of the BNS students wanted to be water engineers, and how many wanted to do different types of civil engineering. And I didn't get a lot of enthusiasm for water engineering, but a lot of people wanted to be project managers.
Because we know that the water management, we deal about water, but in project management they deal only with money. That's what they think. That's what they think. But because they don't, I think they don't know. They don't find the passion for the water. Haven't yet find the passion. For me, the water is way more interesting than project management for me, because I majored in water resource. So water resource, like, it's my life. I learned it for almost like 10 years. So it's more interesting for me than the project managers. Okay.
Yes. Yeah, I think one of the big problems in Indonesia is that your technical specialists are not on the same sort of pay schedule as your managers. And so if you want a good salary in Indonesia, the project management and administration is a far better route than being, a specialist in flood management, for instance.
True.
My brother-in-law, who was brought up in Bandung, has been working in the UK as a flood modeler and a hydraulic modeler for the last 20 years, and he can earn far more doing a technical job than he would be able to earn here.
That's what I told them. That's why I told our students, but I don't know that they listen or not, but I think they still in love in project management. But I think water is more interesting because there are a lot of more problems that we can discuss and model, or anything related to water resource management. Okay.
I apologize for my voice. It's rather harsh because of the flu, but
oh yeah, the flu is harsh right now. Okay, thank you so much, Mr. David, for the opportunity, for the presentation, for the insight about integrated water resource management, the water demand needs fulfillment, and everything. I think I'm personally I get a lot from that, from your presentation, and I hope we can we in another time we can discuss it more about the integrated water resource management. Okay, I think that's it for our presentations today. I want to give it the spotlight to the host Daniel. Time and place is yours.
If I could just add one thing.
Oh, sure, Mr.
The
David. Sure.
Institution of Civil Engineers will be having talks next year, perhaps one every month, and I will be giving a partial talk on reconstruction of the irrigation works in Palu, and then in another talk I'll be talking about infrastructure and MBS and how we can reduce the carbon footprint of cement, concrete, and steel.
Okay. Sure.
So
Yeah.
that's to come.
Okay. Okay. From the IC members, you can talk to Mr. David to follow up that the presentation or the next speaker. Okay. Okay. Thank you. Thank you, Mr. David. Daniel, time and space is yours.
Thank
Yeah,
you,
okay.
Christian Cahyono, for taking over. And thank you to all the speakers for such inspiring insights. I hope everyone find this morning's presentation useful and informative. I'd like to apologize for the question left unanswered due to the time constraint. And before ending today's session, I'd, I'd also like to remind all participants to fill in the exit ticket. While everyone is filling their form of attendance, to wrap up our session today, I'd like to invite everyone to turn on your cameras for a short documentation session. I'd like to invite Fajar to start taking pictures for documentation.
Okay. To all participants, please join the group photo documentation session and kindly turn on your cameras. On the count of 3, we will take a screenshot for each Zoom slide. Okay. 1, 2, 3. Okay, next slide. 1, 2, 3. And next slide. 1, 2, 3. Okay, next slide. 1, 2, 3. Okay, thank you.
Thank you, Fajar. We've also created a WhatsApp group where we share information on upcoming webinars. Please scan the barcode using your WhatsApp camera to join, or if you're unable to scan, click on the link shared in the chat box. Unfortunately, we have now reached the end of the seminar. Once again, the entire Civil and Environmental Engineering Technology Seminar Committee would like to extend our gratitude to our honor speakers and Mr. Christian Cahyono for participating in an integral part of this event. We'd also like to take this opportunity to thank every attendee for your active participation in this seminar. We hope everyone enjoyed the program we worked hard on, and with that, I bid everyone present goodbye. See you on the next seminar. Thank you for your attention. Stay safe and have an amazing rest of the day.
Thank you so much, everybody.
Thank you, Sans. Thank you, Sir Christian.